Dear students, today in this video lecture, I will discuss about routing algorithm. Now, in the previous lecture, we discussed about the link state routing algorithm. With the help of link state routing algorithm, we calculate new routing table and find the optimum route. Similarly, with the help of hierarchical routing algorithm, we calculate the new hierarchical routing table and find the optimum distance between one region to another region. So in the hierarchical routing, first of all, explain some properties of hierarchical routing algorithm like that. Hierarchical routing, unfortunately, again the routing table space are not filled. First, very important point for the hierarchical routing, and there is a penalty to be paid, and this penalty is the form of the increased path length. For example, 1A25C, 1A25C, region 2. But with hierarchical routing, all traffic to region 5 goes to via region 3 because that is the better for most destination in region 5. So now explain. Suppose that several routers are given. For example, routers name are given A, B, C, and next 2A, 2B, 2C, 2D, and next 3A, 3B, 4A, 4B, 4C, 5A, 5B, 5C, 5D, 5. So first we create the region of nearest router. Suppose that region 1 is created of nearest router 1A, 1B, 1C, and region 2 associated with router 2A, 2B, 2C, and 2D. Region 3 are associated with router 3A, 3B, and region 4 associated with router 4A, 4B, 4C, and similarly region 5 associated with the router 5A, 5B, 5C, 5D, and 5E. Now first we calculate full table of 1A from 1A of hierarchical table. Suppose we travel from source router 1A to other router. If we travel from 1A to 1B, 1A to 1A, no line and no hope, any next hope are not required. So dash and dash. If we travel from 1A to 1B, so path is calculated. Only one node is covered, 1A to 1B. So path 1B destination from 1A to 1B, the line is use 1B and hope is equal to 1. Similarly, if we travel from 1A router to 1C router, then destination 1A to 1C, line use 1C and path equal to hope equal to 1. Next, suppose we travel from 1A to 2A. So calculate value 1A to 2A, several paths possible. Suppose the 1A to 1B, follow the line B and send the packet of destination 2A. As another path 1A to 1C, 3B, and this is from 1A to 1C, 1B, and 2A. Three paths possible. We check that which is the optimum route among the several of selected path. So optimum route from 1A, 1B equal to K, number of node is covered during this path equal to 2, and line follow 1B. So if destination 2A, the line choose 1B and hope equal to 2. Similarly 2B, line follow 1B and number of node hope equal to 1, 2, 3, 3. For 2D, line follow 1B and no number of hope. Similarly 3A, destination equal to 3A. Line follow 1C and hope equal to 3. If line follow destination equal to 3B, line follow 1C, 1C and destination equal to 2. If we travel from 1A to 4A, destination is 4A, we follow the line 1C equal to 3 because the path from line 1C is nearest with respect to 1B to that path. So we choose the optimum path during source to destination. If destination equal to 4A, 4B, 4C, now destination equal to 5A. So follow path once equal to 4. If destination equal to 5B, 5B. Follow path once equal to 5. If destination equal to 5C. So if destination 1A to 5C means if follow line B 1, 2, 3, 4, 5. If follow line C 1, 2, 3, 4, 5, 6, 7. Yeah, 1, 2, 3, 4, 5, 6. So nearest line is 5, 5B to 1C, 5C to 1B, and 4 equal to 5. Similarly, we travel from destination 5D, follow the line 1C and path equal to 6 and 5 equal to 1C. Now with the help of this full table of our hierarchical routing, we calculate the hierarchical table for 1A. First column is maintain the destination, second line, and third is here. So we calculate in the same reason. स्टार्ट जो नोड जिस राउटर ने जिस रीजन में स्टार्ट किया था उसके लिए देखेंगे, उसके सारे पॉसिबल देखेंगे 1A 1B 1C। 1A के लिए कोई लाइन नहीं, कोई होप नहीं। नाउ नेक्स्ट वी चेक द वैल्यू ऑफ फ्रॉम destination is 1B, then follow the line 1B and hope equal to 1. Similarly, with destination equal to 1C, follow the line 1C and hope equal to 1. Now in the region 2, we check the region 2, 2A, 2B, 2C, 2D. We select among these 2A, 2B, 2C, 2D minimum of hope equal to 2 and line equal to 1B. So right here 1B 2. And region 3, minimum equal to 1C2. To be select here 1C2. Region 4, 4A, 4B, 4C. Minimum value equal to 3, 1C equal to 3. In region 5, 1C equal to 4. So it is the new hierarchical routing of the calculated with the help of hierarchical routing. Now, next some general point I explain. Suppose that unfold the gain of the routing table space are not free. There is penalty to be paid and the penalty is to form of increased path length. Okay. Next, for example, the best route from 1A to 5C is via region 2. But with hierarchical routing, all traffic region 5 goes to via region 3 because that is better for the most destination region in 5. Similarly, when a single network becomes very large and interesting, question is how many levels should be the hierarchy heavy? The answer is the optimal number of levels for an N router subnet is in N required and total of E and entire per router. Next, routing for mobile host. And routing for mobile host means consider here two factor mobile host and home asset. Now mobile host also categorized in home LAN, simple local area network is associated with the home agent, and foreign agent equal to foreign LAN. And this diamond is represented by wireless cells are connected with the help of wireless cells. So routing for mobile host. When a new user enters in the area, either by connecting to it or just wandering into the cell, his computer must register itself with the foreign agent here. The registration procedure typically works like this. First, periodically, each foreign agent broadcasts a packet announcing its existence and address. A newly arrived mobile host may wait for one of these messages, but if none arrives quickly enough, the mobile host can broadcast a packet saying, are there any foreign agents around? And second point, routing mobile host. The mobile host registered with the foreign agent giving its home address And current data link layer, address and SIM security information is the second point of routing of mobile. And third point of routing for mobile host, the foreign agent contacts the mobile host's home agent, says one your host is over here. The message from the foreign agent to the home agent contains the foreign agent's network address. It also includes the security information to convenience and home agent to mobile host really here. This is three point of the routing for mobile host. Now next point, the home agent examine the security information also, which contain a timestamp, prove that it was generated within the past few seconds. If it is happy, it tells the foreign agent to proceed. Now next point, when the foreign agent gets the acknowledgement from the home agent, it makes an entire its table and inform the mobile host that it is now registered. So ideally, when a user leaves an area, that should be announced to allow deregistration, but many users abruptly turn off their computer when done. So routing mobile host like that. First, packet is sent to the mobile host home address. Now, after this, after this, packet is turned to the foreign agent, showing the second point. After that, then the foreign agent. After this, sender is given the foreign agent address. Now next, subsequent packets are tunneled the foreign agent. These are what step performed in this. So broadcast routing. One broadcast method that required no special feature from the subnet is for the source simply send distinct packet to each destination. It is the definition of broadcast routing. So in this method, waste the bandwidth and require the source to have a complete list of all destinations. So flooding is another obvious candidate, but it generates too many packets and consumes too much bandwidth. So broadcast routing, a fourth broadcast algorithm makes split use for sync tree for the router initiating the broadcast or any other convenient spanning tree for the client. The method makes excellent use the bandwidth generating the absolute minimum number of packets necessary to do the job. Only the problem is that each router must have the knowledge some spanning tree for to be the applicable. For example, broadcaster reverse path forwarding. When broadcast packet arrive at router, the router check to see if the packet arrived on the line that is normally used for the sending packet to the source of the broadcast. So it's forward. So first is so the network here. This network is converted in form of spanning tree or acyclic graph, and each I packet broadcast the packet to each node, showing the sync tree like that. And multicast to do multicasting group management is required. Some way is needed to create and destroy group, and for process to join and lead group, it is important that router know which is their host belong to which groups. So either host must inform their routers about change in the group membership, or router must query their host periodically. So either way, router learn about which of their hosts are in which group. Router tell their neighbors, so the information propagates through the subnet. Like that. Suppose to do multicast routing, each router computes the spanning tree and covering all other router in the subset. This is graph, and this is so the multicast tree for group 1, and only one group are connected by with the help of this spanning tree. And meshes various ways the pruning spanning tree are possible. The simplest one can be used. The linked state routing is used, and each router is aware the complete subnet topology, including which host belong to it. Then a spanning tree can be pruned the starting at the end of the each path and working toward the root, removing all routers that do not belong to the group. So multicast routing with the distance vector routing whenever a router with no host interested in particular group and no connection to the other router receive a multicast message. For that, it respect with the message telling the sender not send any more multicast of the group. So source specific multicast is scale poorly to large network, n groups, m member, and total n entries like that. This is the example of multicasting. So simply we can say that if अगर हम बात करें multicasting, broadcasting, so broadcasting at a time, each message are put each of number of existing node and route. Simultaneously forward the message to all nodes. While in multicasting routing, we choose the selected group and only forward the message on the selected group, not all nodes. So in broadcasting, number of messages flooded all nodes, therefore required more bandwidth required, while in the multicasting only send message only particular group, so less bandwidth required with respect to the broadcast. So today this broadcasting and multicasting and hierarchical routing are completed. If any doubt, you opt